Welcome back to Science Modernizers. In today's video, we are going to see the GBH is a Tokyo of 2023 physics question proposed by students. That is the question number 3. So let's get started with the video. So the question statement says define simple harmonic motion. The B part says figure 3 shows the position of an object undergoing simple uniform circular motion at t equals 0 seconds. A light shines from above and projects the shadow of the object on the screen below the circular motion. So we get the object as seen on the screen. This is the object attached at one end of the circle at time t equal to 0. The shadow projected is observed at x, and at O we have the shadow observed at O, and at y we have the shadow projected at y. So definitely at all points along the circle at all points along the circle, the shadow of this object shall always be projected or shall always be observed between x and y. And as the object keeps on moving around the circle, we are going to observe a to and fro movement along x and y, and that motion is simple harmonic. So the object makes 300 revolutions in 1 minute. The motion of the object between x and y is simple harmonic motion whose displacement is from equilibrium position at O is given by x is equal to a sine omega t plus phi. So from here we get that they said by taking the displacement to the right to be positive, that is from O going rightwards, it's positive. A is Roman 1 says determine the value of A, omega, and phi. So we have to determine the value of the amplitude, omega, the angular frequency, and phi, which is the phase difference. The next is what will be the value of the velocity with which the shadow passes through O. So let's get started and get a proposed solution to this problem. So the first thing is we have our setup as shown, and we see that at all points in this circular point, the shadow of the ball or the object shall always be projected perpendicularly to the screen, and the image is always going to be observed between x and y. So the first question was define simple harmonic motion. So simple harmonic motion, also known as SHM, is defined as a motion in which the acceleration of a particle is directly proportional to its displacement and opposite in direction and directed towards a fixed point. So definitely this object which we see xy will always oscillate between x and y. So we have to calculate the amplitude, and we see that if this object always oscillates between x and y, then the maximum displacement from mean position is what we call the amplitude. So the amplitude will be the distance from O to X or the distance from O to Y. So definitely um, for all objects undergoing simple harmonic motion, we always know that it follows or obeys the equation A is equal to negative omega squared x, where omega there is the angular velocity. So the B part says you calculate the amplitude. So in the equation x is equal to a sine omega t plus phi, a is the amplitude of the wave, which is the maximum displacement from mean position. So we get that the magnitude or the distance between x and y is equal to 100 centimeters as shown. So but the displacement from mean position right up to one of its extremities is the amplitude, and therefore this distance will simply be xy divided by 2. So the amplitude is given by 100 divided by 2, which is 50 centimeters, which is equivalent to 0.5 meters. So let's find omega and phi. We know that omega is equal to 2 pi f, where the frequency is equal to the number of oscillations divided by the time taken. So we get that the number of oscillations was 300, and so we can compute the frequency to be 300 divided by 1 minute, since the object performed 300 oscillations in 1 minute. So 1 minute is equivalent to 60 seconds, and there we get the frequency in hertz, that's 5 hertz. So from there we can deduce that omega will be equal to 2 pi times the frequency, which is 5, which gives us 10 hertz per second. Now to get the value of phi, we know that at time t equal to 0, the object is at the point. The image of the object is observed at x, and x, since this, the height is positive, so from 0 to y is positive, so from 0 to x will be negative, so x will be equal to negative a. We replace it in the equation of the wave, where x is the displacement at any time t, but at time t equals 0, x was equal to negative a, and we get that negative a is equal to a sine omega times t, which is 0 plus phi. So making phi the subject, we get that sine phi is equal to -1 from where phi is equal to sine inverse of -1. But sine inverse of -1 gives -pi/2 radians. So that is the phase difference. Now the next was the velocity of the particle. So the velocity of the particle performing simple harmonic motion is given by v is equal to omega into e squared minus x squared, where x is the position at any time t along the profile, whereas a is the amplitude. Now, when it passes at equilibrium position, which is the point O here, x the displacement is equal to 0, and therefore x will be equal to 0. So v will simply be equal to omega a, which is the maximum speed of the particle. So with v equal omega a, we calculate the speed at mean position. Since we know omega is equal to 10 pi and a was 0.5, we get that v is equal to 5 pi meters per second. So this brings us to the end of this video. If you have any question, you can drop it in the comment box. Thanks for watching and see you in the next video.